Hello and welcome to Arupe Virtual Learning Institute AP Computer Science course. My name is John Maxwell. Today we're going over inheritance. And although it isn't a topic on the AP exam, it certainly should be included in an introductory Java class. We won't go into all the nuances of it, but we will introduce you to the topic so you'll be able to complete this week's assignment. On the right, we have a vehicle class, and we can see that on line 2 we have public class vehicle, and it has as a vehicle a model, a make, a power, 1 for gas, 2 for diesel, 3 for electric, 4 for human. Because a vehicle could be a bicycle, it could be a car, it could be a motorcycle. Hey, it even could be a covered wagon. Anything that qualifies as a vehicle would certainly be modeled by this class. And of course, we have a default constructor, and we have a constructor that takes in the make, the model, and the year, and the power source, and it takes these parameters and assigns them to the instance variables up here because make is a parameter and make is also an instance variable. We differentiate the two with this dot make equal make, meaning this dot make refers to the instance variable and make refers to the parameter. It's well and wise to do a toString, and it returns a string representation of the object, and then below we have set and get methods, accessors, and modifier methods. And this follows the pattern of a typical class: instance variables, constructors, accessors, and modifiers. Notice it also does a comparison of two vehicles by year. And you can compare them in any particular way, but we have a comparison by year. So that's all pretty standard. We have a vehicle class, and it has a full array of methods. However, on the left, we have a car, which extends vehicle, and that is essentially the key word, extends, when we're talking about inheritance. So it's a lot more brief of a class because in extending vehicle, it has access to all the public parts of the vehicle class. So if I wanted to create a car and ask it to set the make, I could because it's a public method of the parent class. So a little bit of vocabulary: vehicle is sometimes referred to as the parent class, the super class, or, well, those two. Okay. And the child class over here, cars, obviously referred to as the child or the subclass. Occasionally it's called the derived class because it's derived from vehicle. But again, everything in the car class is specific to that. We have a toString and a get liters because a car has 2.0, 2.4, 2.5 liters, which refers to the volume of gasoline that it burns in any one particular combustion. So we'll look at this a little bit more. So we have our own constructor: make, model, year, power, and double liters, right? So it adds a parameter there. But what happens is we call a method super, referring to the superclass, which is the vehicle class, and we send these three values that came in as parameters over to line 12 in constructing a vehicle before we finish the construction of a car. So the super statement in a child class constructor needs to be the first statement within the child class constructor. You couldn't switch these lines 7 and 8 here so that super comes after assigning leaders, because it would violate a rule that the call to the parent class constructor using the super keyword, okay, has to be the first statement in the child class constructor. Moving down, it's certainly possible to override some of the parent class methods, and we do this in toString, okay? Because the representation of a car is a bit different, or we want it to be a bit different than the representation of a vehicle. So to do this, we call super.toString, which calls the parent class string, toString method over here, but adds information about the leaders. So you can kind of see this down here where I create a car called a Honda Accord 2014 with the leaders 2.0, and you can see that it returns when this program runs both the parent class representation of toString and the child class. And you do this by calling super.toString to access a method in the parent class. And then it has its own get leaders, and I suppose it should have a set leaders method, but it has its own methods as well. But it can use everything that is a part of the parent class, except it can't access the private instance variables. Those are blocked off from even access by a child class. So let's look at the tester here. Okay, the tester is where I create a car, and you know that we call the child class constructor over here in line 6. Coincidentally, line 6 over here. And it in turn calls the vehicle constructor with the super statement right here. And then it sets the leaders to 2.0. Now, I didn't show you another class, which is a motorcycle class, and I'll just put that over here. Not only can car extend vehicle, but motorcycle can. And the power of a motorcycle is typically measured in cc, cubic capacity. Again, another thing referencing combustion, how much cubic capacity does it have? And so notice again the call to the parent class constructor, get cc, and a toString method that's overridden but calls the parent class constructor. So here I'm creating a motorcycle, and notice c.model, okay, get model over here. We don't find a model, get model method within the car class. However, note that it can use a parent class method that is defined with a public scope. So that's kind of interesting. One of the key takeaways for inheritance is the idea that there's code reuse. Any vehicle can, any car or motorcycle or any subclass can use its parents' public members. So that code reuse, okay, now having to write get model method again in the car class is a number one reason why inheritance is useful, okay? And you can have multi-levels of inheritance. So you could have public class SUV extends car. All right, so you can do that to multiple levels. And what happens is there's code reuse all the way up the level. Now, you have to define them pretty carefully, okay, so that works, but you can do that and create a multi-level inheritance, hierarchical inheritance structure. Previewing next week's topic, we have something called an array list, which is a class-based, you can see it imported up here, a class-based array type. You know, it's sort of like array. It has a zero index. It takes only objects or types, objects, right? Only objects of one type. So in this case, I create an array list of vehicles. And I can add both the car and the motorcycle to the array list, which brings up an important point, okay? As referenced in other videos that you will see, the car is a vehicle, and we're going to put quotes around the two words is a, because it's something that exists in talking about Java inheritance. Is a, we say it is a relationship, which means a car and a motorcycle is a vehicle, are a vehicle in the case of plural, right? So you can easily put all the vehicles in one array list with a top level type vehicle. And that's enough of that, okay? But we also want to just briefly talk about the compare to method, and I will do that in a second. Okay, I'm going to bring this all back over here and then take vehicle out and say, oops, I wanted to take vehicle out. There it is. Okay, and look at the compare to method. If the years are equal, then we're going to return 0. If my year comes before your year, I'm going to return -1. And if my year comes after your year, I'll return 1. So it follows the rule: 0, negative, or positive number. I happen to be using -1 and 1, which is frequently done. But it's 0, negative number, positive number, typically for a compare to. So let's look at that vehicle tester class again, and looking for the mouse, here it is. We have C dot compare to B. And so C is the object or the implicit parameter that is calling the compare to method, also known as this. And so we compare the instance information year to the vehicle B, as in get year. And notice what I'm comparing are a car and a motorcycle. So that's because I set that up as taking a vehicle parameter. I didn't even mention that in class last night, but like, it takes any vehicle. So what happens is you can compare all different types of vehicles with this compare to method, again returning 0, -1, or +1 or negative value. And the Honda, which you can see is 2014, is older than the Harley, which is 2023. Okay, so that's a brief description of inheritance. I hope it clarified some things from you. And good luck with the assignment. Reach out if you have any concerns. Thank you for watching.